Hey everyone, this is Bhargav Suthar and today we will learn about what is a lattice. Now in this today's session we will discuss what is a lattice and some of the examples. So first let us understand a lattice, the definition. Okay, so a lattice, it is a poset A less than or equals to in which every subset AB of A has a least upper bound, that is LUB, and a greatest lower bound. So that means every subset have LUB as well as and GLB. Now how to find LUB and GLB, that we already know, that we discussed in previous sessions. Fine. Now what are the lattice operators? So in lattice, the first one, now LUB of A and B, it is denoted by this symbol A or B, and it is known as this A join B. Fine. So this is the symbol. This means LUB of A and B. Now in same manner, this greatest lower bound of A and B, it is denoted by this A and B. So and it is known as this A meet B. So A join B means LUB and A meet B means GLB. Fine. Now let us discuss example. So the question is, determine whether the following Hasse diagram represent lattice or not. So we have given the Hasse diagram. Fine. Now to check whether it is a lattice or not, all we have to do, we need to have LUB and GLB for each and every pair. Fine. So we will first create a GLB table as well as LUB table and check whether all the pairs have GLB and LUB or not. Fine. So first let us draw the GLB table. So this is the GLB symbol. Now how many points are there? We have 4 points. So just name it as A, B, C and D. We need to find the LUB for each and every pair. Fine. So just in row A, B, C, D, in column. So just write in column ABCD and also here ABCD. Fine. Now A. Now the LUB of A and A. So what will be the LUB of A and A? So LUB and GLB of A and A will be this A itself. So it will be A. Now LUB of A and B, least upper bound of A and B. So this is A and B. So least upper bound, so it will be B. Okay. Now A and C. So A and C. So what will be the least upper bound? So that will be C. Fine. Now A and D. Now A and D. So upper bound will be D. Okay. Next. Now B and A. So as it is AB it was B. So now BA it will be B. Fine. Now BB. So BB, it is the same point. So it will be B. Now B and C. Now this B and C. So least upper bound will be C. Now B and D. B and D. So it will be C. Now consider C. Now what will be the A? Now it was in AC it was C. So in CA also it will be C. Now and now CB. So in BC it was C. So here in CB it will be C. And then CC. So obviously it will be C as it is the same point. Now CD. So C and D. So least upper bound. So it will be C. Okay. So as you can see that this C is the upper bound of the whole graph. So that means whenever C will be there, so the answer will be C. Fine. Now for DA. Now in AD it was D, so it will be D. Now DB. So in BD it was C, so here it will be C. Now DC. So in CD it was C, so it will be C. And DD, it is the same point, so it will be D. So now the same graph, and now we will construct a GLB table. Okay. So this is the GLB symbol. Now in column we will write A, B, C and D. And also in this row we will write A, B, C, D. Now A and D. Now it is the same point, so greatest lower bound will be same A. Now A and B. Now A and B, and here it is the lower bound and the greatest one, so it will be A. Now A and C. A and A and D. A. Why? Because C. You can see that this A is the greatest lower bound of the whole graph. So whenever A will be there, so the answer will be A. Fine. Now B and A. So BA. So in AB it was A. So A. Now BB. Now B and B. So as it is the same point, so it will be B. Now BC. Now this B and C and the greatest lower bound. So that means this B. Okay. Now B and D. B and D. So greatest lower bound will be A. Then C. Now CA. Now in AC it was A. So it will be A. Now C and B. Now in BC it was B, so here it will be B. And CC, so that means it is the same point, so it will be C. Now C and D. C and D, greatest lower bound, so it will be D. Fine. Now next D. Now this is D. Now D and A. Now in A and D it was A, so it will be A. Now D and B. So in BD it was A, so here it will be A. Now D and C. In C and D it was D, so here it is D. Now D and D. So greatest lower bound of the same point, that will be D. So now here you can see that every subset has a least upper bound as well as the greatest lower bound. So we can say that it is a lattice. Fine. So this is how you can conclude whether it is a lattice or not. Now let us discuss a second example. So the question is, let capital A be set of vectors of positive integer m and the relation is divisibility on A. Okay, so the divides relation is there and the set of vectors of positive integer m. Fine. So m is 45 is given and show that the superset it is a lattice. Okay, so this is the question and we need to check whether it is a lattice or not. And we don't have any relation or we don't have any Hasse diagram. So in this example, everything it is covered. So first we will write a relation, we will draw a Hasse diagram, then we will find GLB and LUB, and then we will conclude whether it is a lattice or not. So this is a good example. So here A is the set of vectors of M, that is 45. Now what are the vectors of 45? So it will be A. So 1, 3, 5, 9, 15 and 45. So they are the vectors. So hence in A these many points will be there. Okay, so A is done. Now also the relation is what? It is the divides relation. So that means X divides by. Fine. So now we will write a relation. So the relation will contain so many points like this. Okay, so this many entries will be there. How? See, each and every point divides itself. So 1, 1, 3, 3, 5, 5, 9, 9, 15, 15 and 45. These many pairs will be there. Then 1 divides 3, 1 divides 5 and 1 divides 45. Up to this, that will be there. Now 3 divides 9, 3 divides 15, 3 divides 45. Then 5 divides 15, 5 divides 45. Then 9 nothing. Now and 15 divides 45. So this will be the relation. So relation is done. Now we will construct a Hasse diagram. Fine. So R is given. So the Hasse diagram will be like this. So see, we have directly drawn the Hasse diagram, and in case you don't know how to draw or how to construct a Hasse diagram, you can go for the previous videos. Okay. So this will be the Hasse diagram. I am not discussing it. So first we will create a LUB table. Okay. So how many points are there? So total 6 points are there. So in column we will draw this 1, 3, 5, 9, 15 and 45. Fine. And also in column same man 1, 3, 5, 9, 15 and 45. Now 1, 1. Now LUB of 1 and 1. So as it is the same point, so it will be 1. Now LUB of 1 and 3. See, least upper bound of 1 and 3. So it will be 3. Now least upper bound of 1 and 5. So it will be 5. Now LUB of 1 and 9. So it will be 9. Then LUB of 1 and 15. So 1 and 15. It will be 15. And 1 and 45. It will be 45. Fine. Now for 3. So 3, 1. So in 1, 3 it was 3. So here it will be 3. Now 3, 3. As it is the same point. So 3, 3. Now 3, 5. So 3 and 5 and least upper bound of 3 and 5. So that will be 15. Then 3 and 9. So 3 and 9. It will be 9. Then 3 and 15. So 3 and 15. It will be 15. And 3 and 45. So 3 and 45. So it will be 45. Okay. Now then 5 and 1. In 1, 5 it was 5. So in 5, 1 it will be 5. Now 5 and 3. In 3, 5 it was 15. So here it will be 15. Now 5, 5 as it is the same point. So it will be 5. Now 5 and 9. So 5 and 9. So least upper bound. So that will be 45. Now 5 and 15. So 5 and 15. It will be 15. Now 5 and 45. So it will be 45. Now as you can see that it is the upper bound of the whole graph. So this column, whole column will be 45. Now 9. Now 1 and 9. In 1 and 9 it was 9. So here it will be 9. Then next 9 and 3. So 9 and 3. So it will be 9. Now 9 and 5. In 5, 9 it was 45. So here it will be 45. Now 9 and 9. So as it is the same point. So it will be 9. Now 9 and 15. This 9 and 15. So that is 45. And 9 and 45. again 45. Then next 15 and 1, in 115 it was 15, so 15. Then 15 and 3, in 315 it was 15, so 15. Now 15 and 5, so in 515 it was 15, so 15. And same in 15 and 9, in 9 and 15 it was 45, so here 45. Then 15 15, as it is the same point, so 15. Now 15 and 45, so 45. And last 45. Now see, 45 is the upper bound, so all the entries will be 45, so it is very obvious. So you can see that there is a least upper bound for each and every pair. Fine. Now again we will construct this LUB table. Fine. So in same manner, this table will be there in all in column 1, 3, 5, 9 and 15 and 45. Okay. And also in row it will be 1. Now 1 and 1, so GLB of 1 and 1, as it is the same point, it will be 1. Now 1 and 3, so the greatest lower bound of 1 and 3, so it will be 1. Now you can see that this 1, it is the GLB of the whole graph, so this whole row will be 1, so no need to check for everything. Now 3 and 1, in 1 3 it was 1, so 1. Now 3 3, as it is the same point, so 3. So 3 and 5, then 3 and 5, so it will be 1. Then 3 and 9, 3 and 9, it will be 3. Then 315, it will be 3. And 345, it will be 3. Now 5. Now in 5 1, so in 1 5 it was 1, so 1. Now in 5 3, then 1. Then 5 5, so 5. Now 5 9, so 5 and 9, so it will be 1. Now 5 and 15, so it will be 5. And 5 and 45, so it will be 5. So this is how you can create the GLB. Now I'm just directly writing the answers because it is very easy. So fine. So these will be the answers. Okay. So as you can see that it is the you can see that there is a GLB for each and every pair. Fine. So here every subset has upper bound as well as a greatest lower bound. So we can say that it is a lattice. Okay. So this example is the important one. Thank you.